morning, everyone. Myself, Professor Nikhil Mukta from SND College of Engineering, Yaula. Today we are going to discuss topic on transformer design. So we are going to discuss about transformer design. So today topic to be covered is power transformer. So what is power transformer? Power transformer is a static device which transforms electrical energy from one circuit to another without any direct electrical connection with the help of mutual induction between two windings. It transfer power from one circuit to another circuit, without change in frequency. So working of transformer. Transformer works on the principle Faraday's law of electromagnetic induction. Actually, mutual induction between two or more windings is responsible for transformation action in an electrical transformer. According to the Faraday's law, rate of change of flux linkage with respect to time is directly proportional to induced EMF in a conductor or coil. EMF means electric motive force. So basic theory of transformer. Say if we have one winding which is supplied from the one source, which means whenever the alternating current through winding produce a continually change flux or alternating flux that surrounds the winding. If any other winding is brought nearer to the previous one, obviously some of the portion of flux will link with the second. As the flux is continually changing in its amplitude and direction, there must be a change in flux linkage in the second winding or coil. Between these, there is no frequency changes. There is no frequency change in transfer of power. According to the Faraday's law of electromagnetic induction, there must be an EMF induced in the second. Means the EMF should be induced in the secondary winding. If the circuit of latter winding is closed, there must be current flowing through it. This is the simplest form of electrical power transformer, and this is most basic working principle of transformer. Power transformer, the rating of power transformer is very high. They are used at generating stations, that is at the start of high voltage transmission line, and at receiving and substation, that is at the end of high voltage transmission line. Or whenever we apply alternating current to an electrical coil, there will be an alternating flux surrounding that coil. Now, if we bring another coil near the first one, there will be an alternating flux with that second coil, but there is no frequency changes between primary and secondary coil. As the flux is alternating, there will be obviously a rate of change of flux linkage with respect to time in the second coil. Naturally, EMF will be induced in it as per Faraday's law of electromagnetic induction, as we have discussed earlier. This is the most basic concept of theory of transformer. The winding takes electrical power from one source is generally known to a power transformer. Here is a transformer, first coil, second coil, flux, alternating source and induced voltage. So this normally operate at full load. Power transformer are operate at full load, means 80 to 90% of their capacity. Power transformer may be two types. One is step down or step up transformer. These are designed to have maximum efficiency at full load or near full load. Here is diagram of a transformer, main parts of the transformer. The winding which gives the desired output voltage due to mutual induction in the transformer is commonly known as secondary winding of transformer, because heat is getting transferred from primary winding to secondary winding. So here is example of second winding. So there is primary winding on left hand side and secondary winding on right hand side. There is core in between. The transformer, the above mentioned form of transformer is theoretically possible but not practically, because in open air very tiny portion of the flux of the first winding will link with second. So the current flows through closed circuit of latter will be small in amount that it will be difficult to measure. The rate of change of flux linkage depends upon the amount of linked first flux with second winding. So it is desired to be linked to almost all flux of primary winding to the secondary winding. This is efficiently done by placing one reluctance path common to both of the winding. Though this low reluctance path is called as core of the transformer, through which maximum number of flux produced by the primary is passed through and linked with the secondary winding. This is the basic theory of transformer. So core type transformer, in this type transformer winding covers the large portion of the cores. Windings that is low voltage winding or high voltage winding are wound to the limb, which is made up of lamination. So here is main constructional parts of the transformer. There are three main parts of the transformer are primary windings of transformer, which produce magnetic flux when it is connected to electrical source. Magnetic core of the transformer, the magnetic flux produced by the primary winding that will pass through this low reluctance path linked with secondary winding and create a closed magnetic circuit. So in magnetic core, the lamination which connects two vertical limbs is called as yoke. Depending upon the material used for core, its area may be larger than limb area or equal to limb area. So here is secondary, it is the main part of the transformer, that is secondary winding of transformer. So in secondary winding, we get the final output of the power transfer, in which heat will be dissipated to the surrounding. So here is one of the diagrams of core types of transformer which is used in power transformer. So in next lecture we will study about the yoke part of the transformer and the core type and shell type transformer. Thank you. Have a great day.